This video is for stretching and shrinking problem 1.4, keeping things in proportion, scaling to solve proportions. Our LEQ is how do you set up and find a missing value in a proportion. Just as a refresher, a proportion is when two equivalent ratios in fraction form are set equal to each other, and it's a form of an equation. So an example proportion would be 1/4 is equal to 3/12. Both of these give me the decimal value of 0.25. They are equivalent. This is a proportion. What we're going to talk about is how we can solve proportions that represent word problems or ratios, and how we can use proportions to scale ratios. So let's look at an example. Here's our situation. Among American doctors, men outnumber women by a ratio of 12 to 5. We should realize this or recognize this as a part-to-part ratio. There are 4 different ways that we could write this as a proportion. The first way, we can write the ratio of known men to women doctors, so that would be the left side here, and complete the proportion of the ratio's actual numbers of doctors. We want to figure out how many women would there be if there are 6,000 men. That's kind of our goal. Let's add that in here. Okay, so there's the problem that we need to solve. So the first way we do it, like we were talking about, 12 men to 5 women. If there are 600,000 men, how many women would there be? So we're solving for how many women. That's the first way to write it. The second way to write it is to write the ratio of women to men, so 5 women to 12 men, and complete the proportion with how many women if there were 6,000 men. Notice that these two are really the same thing. It all depends on whether the men are in the numerator or the women are in the numerator of each side of my proportion. The ones on the right are technical ways that we can write the proportion, but these are not ways that I would suggest. The first one, write the ratio of men to men, 12 men to 600,000 men, and then complete it with the women. Or the other way around, you could do the same things, except you have, once again, whether or not the larger or the smaller numbers in the numerator. I don't like and I don't suggest these methods because I like to keep the labels on the top the same. So over here I have men and men are on the top. Over here women and women are on the bottom. In the bottom one, women and women are on the bottom. Men and men are on the top. I like to keep them the same because it helps me, and I think it really helps you to keep all your quantities kind of organized. So if I were to solve this now, I have 12 women over 5 men. I'm looking at the top option here, equals 600,000 men, and, or I'm sorry, yeah, 600,000 men, and how many women? And I do have my labels wrong over here. I apologize for that. This is 12 men and 5 women. Notice that I have men on the top side of both proportions and women in the denominator of both proportions. I'm going to think of this as like 2 equivalent ratio or 2 equivalent similar pictures now. I'm going to draw my arrow from what I know to what I want to know. So from 5 to x and from 12 to 600,000. I'm going to find my scale factor by taking 600,000 and dividing it by 12 and getting a scale factor of times 50,000. And then I'm going to use that. I'm going to take 5 times 50,000 to get that there would be a total of 250,000 women. And that's how I would solve that proportion. If I would do the same thing with the other one, again, I would take 600,000 divided by 12. I'm going to get the same scale factor times 50,000. It all depends on which one I put on the top and which one I put on the bottom, and it doesn't matter which one you do. So let's look at one other example here, and I've kind of listed these out by steps to kind of help you see some steps that you should use when you solve these. So this time the proportion isn't given. We have to write the proportion. Our problem here is Pat the painter mixed 3 pints of yellow paint with 4 pints of green paint to make a very nifty new color. He used 27 pints of yellow. How many pints of green did he need? So the first thing we want to do is determine the labels and put them in the proportion. So the things that I'm talking about here are yellow and green. Yellow and green. The pints don't make a difference to me in this case. So I like to start my proportions with something simple. Line equals line. I know I'm going to need them both. I put my labels in. I have yellow on the top and green on the bottom. Once again, it doesn't matter. You could do green on the top if you wanted yellow on the bottom, but I suggest that match top and top labels and bottom labels. Step 2 is to insert the quantities we know. We had 3 pints of yellow with 4 pints of green, and we had 27 pints of yellow, and we're trying to figure out how many pints of green. So I'm going to put my variable x there. And now I need to solve, and we know how to solve these. Find the scale factor between the two quantities. So I'm going from 4 to x. Always start by drawing the first arrow to what you want to know. I'm going from 3 to 27. To find my scale factor, 27 divided by 3 is going to give me times 9. And then step 4, I'm going to take 4 times 9, and I'm going to get there's 36 pints of green. Okay, so that's all I needed to do there to solve the proportion. 4 easy steps. Set it up, match your labels top to top, bottom to bottom, insert what you know, draw your arrow from what you know to what you want to know, find your scale factor, and use it to solve.